Hi, welcome back. Now let's see a little bit about triangles, okay? Now, before we do that, we have to establish some classifications that we do on triangles. We have two types of classifications. One is when we are classifying them as per their sides, okay? So, let's see when we are talking about their sides. Oops, I'm sorry. Let's see about their sides. Well, when we have a triangle which has, and one thing that is important to notice, okay, when I do this, it means both sides are the same, and because I have two marks in here, that side is different, okay? So when they have two equal sides and one is different, we are going to say that this triangle in here is going to be, let me see, okay, let me just write this is going to be an isosceles triangle, okay? An isosceles triangle, okay? Now let's see another one. Let's take this pen again. So when we have a triangle which has all the three sides being equal, like this, this, and this. And remember, when I just put one mark, I could put three marks, it doesn't matter. It is not the amount of marks that are going to do any difference, okay? But they all have to have the same numbers of marks. 2, 2, 2, 3, 3, 3, 1, 1, 1. It doesn't matter, okay? I'm going to stay with just one because it's less information. Okay, so when all the sides are the same, we are going to say this is an equilateral, okay? Equilateral. An equilateral, oops, equilateral triangle, okay? All the sides are the same. And what about when all the sides are different? We could have that. Maybe like this, this, and this. Well, this side has one length, this a different one, and this has a different length. All three sides are different. We say this one is an Scalene, okay? Yes, with this Scalene. Scalene. Okay, well, this is about their lengths, okay, the sides of their lengths. We can also classify triangles about their angles. And let me just how can I just want to move, no, leave it there. Okay, what about their angles? Okay, there is a different classification. And what about their angles? Let's see. Well, when we have, it's not too ugly, when we have this triangle, it doesn't matter the sides, okay? We're just interested in the inner angles, okay? Okay, we just put a dot in the middle. It is a square with a dot. It means that this angle, it is 90 degrees, okay? This is 90 degrees, okay? That angle and that angle is 90 degrees. That angle and that angle, that, and so on, okay? The cube has only right angles, okay? We call it 9 degrees or a right angle, and that is because, and that is why that triangle is going to be called a right triangle. Okay? Now, there is another one in here. This is the right triangle. I think you can put everybody here. There is a right triangle. Then, what happens when we have all the angles being the same? Actually, it's not that the angles are going to be the same, okay, but it is an acute. I'm sorry, okay, I just confused it. So let's just call it alpha, this one beta, and this one gamma. Okay, what happens? Oh, let me just put separation here. We don't want it to confuse. What happens when all the angles are the same? I mean, not the same. What happens when all the angles like this? When alpha, it is smaller than 90 degrees. Beta also is smaller than 90 degrees. And also gamma also. Oh, it's we write angles with Greek letters, okay? And when everybody is smaller than 90 degrees, what do you call that one, that triangle? We call an acute. Acute triangle. So acute triangles are triangles which have all the angles, all the internal angles smaller than 90. Okay, what about this one? Well, this is smaller and smaller than 90. Yes, but this one is 90. 90 is not possible. Okay, I didn't write smaller or equal to. I just wrote smaller than. Okay, and we have another type when we have an angle which is bigger than 90 degrees. Let's put it like this. This is a triangle, and we're going to see that this angle in here, it is greater than 90 degrees. In this case, we're going to say that this is an oblique or an obtuse triangle. Okay, so we have to see all those things. Okay, so about their sides, it could be isosceles, when we have two sides being the same and one is different. We have also the equilateral triangle, where all the sides are the same. This is going to happen, for instance, in the hexagon, when if we just take the hexagon, the honey, right, the honeycomb, and if you just divide with all triangles inside, and just like that, this honeycomb, right? And if you just divide with triangles, all of those 6 triangles, each one of those is going to be an equilateral triangle. Okay, so we can have an isosceles triangle, we can have an equilateral triangle, and we can have an scalene. Scalene is when everything is it is different. Okay, maybe this is 2, this is 1 is 3, this one is, I don't know. We have to just to see those, okay, with a compass or something like that. Well, anyway, about their sides, it could be isosceles, equilateral, or scalene. And what about their angles? Well, when we have a 90 degrees, when we have a right angle, it's going to be the right triangle. When all of the angles are smaller than 90 degrees, we are going to call acute, and when one of them it is greater than 90 degrees, we are going to say oblique. Okay, now it's only already 80 minutes just to teach you that, but anyway, this is very important. Now let's just play a little bit. Well, I'm going to draw some triangles in here. Again, let's pick the pink one, and let's say that we're going to draw, oh, one thing. Imagine that this cube has side 10. So every single edge, okay, every single edge has 10 in length. I'm not going to put everybody here, okay, but it is 10, okay, trust me. Because, okay, let's put everybody 10, 10, okay, forgot this one, the front one, 10, this one, 10, okay, everybody's 10. Okay, now another property of squares, because the faces are squares, right? Let's see a property in here. If this is 10 and if this is 10, what's going to be that? No, It was supposed to be lighter. Oh, this one. What's supposed to be that? That is supposed to be 10 square root of 2. Okay, so the square diagonal, it measures exactly the sides multiplied by square root of 2. We have to know that. Okay, and let me just see what's going to be the diagonal for the cube. Okay, it is square root of 3. I just had to make Pythagoras in here. Okay, where? Okay, this is 10. I have to make this Pythagoras in here. This would be 10. This is the cube diagonal. This is going to be 10 square root of 2 because it's going to be, I'm just doing this triangle here, okay? This triangle I'm doing here. This is 10. This is 10 square root of 2 because it is the base diagonal, and this is going to be what we want to look for. Well, if we just apply Pythagoras, it's going to be what? This square root is going to be 10 square root plus 10 square root of 2 square root. Okay, this, you can see that easily that this is going to be 300, and in the end it's going to be square root of 3. Okay, just to explain you what I did in here. Everything's math. Okay, so the cube diagonal, let's make it very, the cube diagonal was supposed to be black, so the cube diagonal is going to be 10 square root of 3. Okay, it's interesting that you know those. Okay, but if you don't remember the diagonal, the cube diagonal, like I didn't, you just have to make Pythagoras and that's it. Okay, now once we know all that already, a lot, okay, in minutes, but now let's start the actual learning here. Okay, I mean half of the learning, right? The first half is this is very important. Now if I just ask you this, imagine this triangle in here. This one. Okay, what is this triangle? Is it going to be what? Well, first let's talk about their angles. It's going to be a right triangle, right? Why? Look, we'll have a 9 degrees in here. Can you see? I'm just drawing this triangle here, and this is a right angle, this one. Okay, what about it? Well, this side is 10, this side is 10, and this is going to measure what? 10 square root of 2. So this triangle here is going to be, well, according to its angles, is going to be a right angle, a right triangle. Okay, right triangle about their angles. And what about their sides? Is going to be what? Try it. Isosceles, right? Why? Because we have 2 equal sides. Okay, this one is going to be different. Okay, now this is one. Another one that we can try in here. Let's make in green. Let's make this one now. Okay, here. Let's take 6 to 8. Okay, now I want to see all the diagonals. Okay, why? Because if I just take all the face diagonals, I'm going to build. Oh, you're going to see. I can't say it before. Notice that I'm taking all the diagonals in here. Okay, you see this triangle 6, 8, 3. This has all 10 square root of 2. Why? Because it is all the faces diagonals, and the face diagonal, because the face is a square, everybody is going to be 10 square root of 2. So you have to memorize. Okay, there is no other way around. You have to remember that the diagonal of the square, it is the side square root of 2. Okay, so can you see? This side is the same as this side, the same as these sides. You see? Meaning that all these sides are equal. So what's going to be the classification of this triangle according to its sides? It's going to be a equilateral. Okay? Equilateral. Everybody is the same. Equilateral. Okay? Okay. What about if we take this triangle in here? I'm trying to find one that has all the different sides. Let's try to make some purple in here. Yeah, I think we can do this one. No, purple. Let's take this light blue. Purple is going to be like that. Now, let me try to find. Okay, let's make this exercise. Find me a triangle which has all the three sides. And what is going to be its name? Down here. Down here. About the sides. Okay, it's going to be a scalene. Okay, it's going to be in scalene. Now, how can you find such a triangle here? Let's see. Maybe. Okay. Well, let's start with this one. Okay, on the bottom we haven't done anything in the bottom. Let's do it here. So let's take this. Okay, one side is 10. The other one must be different. Okay, so it has to be this one. I'm not saying it's going to be possible with this one. Oh no, with this one it's not possible to make it scalene. Let's take this one. This is the diagonal, so this is going to measure 10 square root of 2. Agree? Yeah. Now this one is going to be the side, and the side has length 10. Good. Now, what is going to be the next side, and it has to be a different one? This one, the cube diagonal. You see? Okay. I know it's not very good, because trust me, I tried 30 minutes before preparing this video, just trying to shoot lines in their proper position. It's not very easy. Okay, anyway, 10 square root of 3. Remember the square in here. If we have a square, this diagonal is going to be, if this has side s, is going to be s square root of 2. But if you're talking about a cube, the diagonal of the cube is going to be what? Side square root of 3. Remember that? Good. Now, look, this triangle in here. It has two equal. No, it doesn't have any side equal. Look, why? Because this is 10. Okay, the segment 1, 5, it is 10. Now, the segment 1, 3, it is 10 square root of 2. Why? Because it is the face, the bottom face diagonal. So it is 10 square root of 2. And what about 5, 3? Well, this is a cube diagonal. We have seen it is 10 square root of 3. It is the edge, the cube edge multiplied by square root of 3. You see, so this is going to be an scalene triangle. Okay? So this is going to be, let's just write them. Scalene. Scalene. What about this one? The purple one. Remember, this one is going to be, which one is going to be this one? Two sides being the same. Okay, isosceles, right? This is going to be the isosceles. Don't forget this s, okay? Isosceles. And what about the green one? The green one is going to be the equilateral, right? Okay? You see? Yeah, this video is too huge. I'm going to stop in here, okay? It's more than enough with that video, okay? So this is a very important video about triangles. So see you in the next video for squares.